Hello, I'm Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about a numerical problem on equivalent resistance. Okay, first let's understand this diagram very well. In this diagram, we have four resistors with resistances 1 ohm, 2 ohm, 3 ohm, and 4 ohm. But to do the sum, I'm considering those resistances as R1, R2, R3, and R4, and we have potential difference of the source as V equal to 10 volts, and finally we have electric current flowing through the circuit. Now the sum is determine payday across each of the resistors and also determine the electric current through each. Okay, let's consider the electric current flowing through the circuit as I. I is flowing through the circuit, let's say. Now, to do the sum, it looks like these are in parallel. We need to determine the equivalent resistance first. Then only we can go on to finding the payday and electric current through each. To find this equivalent resistance, we need to first figure out whether it's in parallel and series. Now, if you look carefully, it means in one go, if you see, you might think, oh, it's in parallel. But no, this is not in parallel, because if you see here carefully, then these four resistors don't have a common endpoint, don't have common endpoints, so they cannot be called in parallel. They are in series connection, even though they are arranged like in parallel. In parallel, the main thing is those resistors have to be having a common endpoint, and the arrangement in series can differ. Either they may be end-to-end or they may be arranged like parallel, but it doesn't mean that they will have some common endpoint. Here they're connected in series. So now we can easily find out the equivalent resistance. So let's consider the equivalent resistance as Rs. Then in this case, Rs equal to R1 plus R2 plus R3 plus R4 equal to R1 is 1 ohm, R2 is 2 ohm, 3 ohm, 4 ohm. 1 plus 2 plus 3 plus 4 ohm. To calculate in mind, we get 10 ohm. 10 ohms of equivalent resistance is there, means it's a replacement for all these four resistors. Now whatever we're going to do in the sum is based on Rs, not on these four resistors, because Rs is just a replacement for these resistors. So now we have to move on to finding the electric current through each. Now let's get I. We have considered the total current flowing through the circuit as I, but since this is in series, hence it does not matter. In series, the electric current does not get divided. Only the voltage does get divided. But over here, we have considered I as the total current. So if we get I, then there's no problem in getting the electric current flowing through each, because I is the current flowing through each. So let's get it. Total current flowing through the circuit equal to. Now to do this, let's recall Ohm's law. Ohm's law suggests V equal to I into R, and we have considered the R over here as the equivalent resistance we got in the first step, Rs, I into Rs. So I would be equal to V by Rs, and here V is having 10 volts. We have 10. V by Rs, we got Rs as 10 ohms. We have 10 here too, and the SI unit for current, electric current, is ampere. So A. 1 ampere. And since this is the total current flowing through the circuit, that means 1 ampere is flowing through R1, R2, R3, and R4, with resistances 1 ohm, 2 ohm, 3 ohm, and 4 ohm. So this is our electric current. Now finally, we can move on to finding the potential difference across each of the resistors. So I'm erasing the board to move on to our next part of the sum. Now, as I told you previously, in this case, I was not getting divided, but voltage was getting divided. So we are considering the divided voltages as flowing through each of them. We have considered R1, R2, and R3, and R4. So the potential differences across each of the resistors is V1, V2, V3, and V4 respectively for resistors R1, R2, R3, and R4. Now we can begin our calculation. Again, we're calling Ohm's law, V equal to I into R. So let's do it accordingly. And I did not change, it's not getting distributed over here. So PD across PD across R1 equal to, now this is what we got R1, now V1, that we have considered the potential difference across R1 is equal to I into R. Here I is the same, and here R is R1, that is 1 ohm, to R1, equal to, I is 1, we got 1 ampere, into R1 is 1 ohm, and SI unit of potential difference is volt. We put a capital V, and we get 1 volt. For PD across R1. Next, PD across R2. PD across R2 equal to V2, that is the potential difference across R2, equal to I into R2 equal to I is 1 and R2 is 2 ohms. Again, capital V, 2 volts. So PD across R2 is 2 volts. Now we need to move on to PD across R3 and R4. So I'm erasing the board to move on to the next part. Now, PD across R3. PD across R3 equal to V3, that is potential difference across R3 equal to I into R3 equal to 1 into R3, that is 3 ohms, to 3 whole capital V equal to 3 volts. And finally, the PD across R4. PD across R4 equal to V4, that is potential difference across R4 equal to I into R4 equal to 1 into R4, that is 4 ohms, equal to 4 volts. So we have got the PDs across each of the resistors, R1, R2, R3, and R4. And if we verify these voltages, will result to our initial potential difference of the source, that is 10. And we can prove it, 1 volt plus 2 volt plus 3 volt plus 4 volt is 10 volt. That is the potential difference of the source. So I'm giving you a few moments to look at the sum and think on how it was solved so that it can clear your concept. Hope you enjoyed solving this numerical with me, and please like, share, and subscribe my channel, and stay tuned for more videos. In our next episode, we will talk about a similar kind of numerical. Thank you.